Hello everyone, how are you doing? How's your exam preparation going on? This is Saida Anjum back again. So we discussed about organic, inorganic, and let's come to physical. I have just started the video, so we are going step by step. You can ask me for anything if you want in special in the comment box below. So this is the physical chemistry, which is one more important, very important section for your JEE mains, NEET and your regular exams. Physical chemistry seems very difficult for you just because of the numericals problems, but it is very easy if you understand, and you can score really good in your exams, more than 140 just in a chemistry. So in physical chemistry you can see these are the important topics: the atomic structure, chemical equilibrium, chemical kinetics, electrochemistry, equivalent concept and titration, gaseous state, mole concept, solid state, solutions and colligative properties, thermodynamics and thermochemistry. So in this, how many questions will arise? Especially in each chapter you'll get each question. Especially you'll get more number of questions in electrochemistry. Electrochemistry is very most important. Sometimes you might get 1 or 2 questions maximum than this or less than this, but electrochemistry is important. When we come to the marks, you can see each one question carries 4 marks. So these are all the table, and maximum of 47% of weightage will be there in your exam only from physical chemistry. To understand physical chemistry, there are two very important things. One is your atomic structure and another one is your mole concept. In mole concept, we will be having so much to cover. You can see the second important is mole concept. For going mole concept directly, I will go with the gas laws first. After covering gas laws, I will go to mole concept. So let's start the lecture of the day. Thank you so much. Let's see what's all gas laws. So coming to basic principles, I don't want to take too much. I'm just going to which are very most important. So according to that, the first one I prefer, which is really very important and you'll get questions upon that, is law of chemical combination. Laws of chemical combinations. Okay, so in laws of chemical combination, there are some 4 laws. The first law is law of conservation of mass. Law of conservation of mass. This is a very quite easy one. We read this from our childhood, that law of conservation of energy, law of conservation of mass, law of conservation of this, that. Law of conservation is something which can neither be created nor be destroyed. So we relate that simple sentence, neither be created nor be destroyed, to the respective word. So here it is mass. So law of conservation of mass is mass of a compound in chemical changes. The total mass of a system remains constant. The chemical change can neither create the mass nor destroy the mass. It will stay as it is. You can write down the sentence for this, the definition for this, but that definition is not that important for your JEE main exams, but the problems upon this law are important. However, I'll write the formula so that you can be easily solve the problems. So the formula is total mass of reactants. That means if you consider any of a reaction, there the total mass of reactants will definitely going to be equal to total mass of products plus mass of unreacted reactants. Okay, total mass of reactants is equal to total mass of product plus mass of unreacted reactants. That means if you have taken some 2 moles, then that should be equal to 2 moles. If you have taken 4 moles, that should be equal to 4 moles. The number of moles and the weight of the reactant should be equal to the number of moles and the weight, or the reactants which have been unreacted, or the product which has been already formed. That should be equal. The LHS should be equal to RHS. Next, coming to the second law. The second law is law of definite or constant proportions. Law of definite and constant proportions. So what is this law? In general words, I'll say it is very simple law of definite and constant proportions, where if you say you are preparing carbon dioxide, CO2, okay, you may prepare this from any method, any several methods, but the combination of moles of carbon and moles of oxygen will remains the same, irrespective of methods you are using to prepare this. So definite and constant proportions will be there in that particular compound, however you prepare them. That is law of definite and constant proportions. Example, if I say I am going to burn calcium carbonate, CaCO3, so that will give us CaO plus CO2. And the another example, I'll say heating of sodium bicarbonate. Sodium bicarbonate is NaHCO3. So I am going to get Na2CO3 plus CO2 plus H2O. Here you can see it is not balanced, so let me balance the equation. Balancing equation is very important wherever you go in chemistry. So you can see here also I am having carbon dioxide, here also I am having carbon dioxide. In this carbon dioxide, the moles of carbon and oxygen are same. You don't consider the moles what are here, that is not required. The moles, 1 carbon mole, 1 mole of carbon, this is 1 mole of carbon and 2 moles of oxygen. This is the combination of carbon dioxide. If I write CO, will it be equal to CO2? No. Wherever you go CO2, that is completely CO2. The combination of carbon and oxygen are definite. If I say this one, this is carbon monoxide. This combination is definite. So this is law of definite and constant proportions. You might say, what are all these laws? What that? Law of combination, law of conservation of mass, law of multiple proportions. But the laws are very important and they are very easy to understand. If you understand them, you can easily crack the questions in your exam. So let me revise these 2 laws again. Law of conservation of mass, law of definite and constant proportions. And which are the other 2 laws? We will discuss it now. The third one is law of multiple proportions. Law of multiple proportions. What is law of multiple proportions? It is also very simple. If you see, you are going to combine two elements. If you are going to combine two elements, one element will have constant mass or proportion, and the second element will change its number of moles and masses and everything, and gives you different compounds, not a single compound, different compounds with simple ratios. Example, for the second law I said carbon, I took example of carbon dioxide and I said carbon monoxide. Here also we can consider carbon monoxide and carbon dioxide, but that though those two don't give so much of compound, so I'll take nitrogen and oxygen as example. So you can see nitrogen is one element, oxygen is another element. As I said, one element is constant, second changes. So if I keep nitrogen N2 constant, N2, 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 how many I can prepare compounds using nitrogen and oxygen. So if I keep N2 as constant, let me keep 1 mole of oxygen. It will give you nitrogen, dinitrogen oxygen, nitrogen oxide. It almost forms 5 oxides. Nitrogen forms 5 oxides using the same constant N2. So N2O is possible, N2O2 nitrogen peroxide is also possible, N2O3 is possible, N2O4 is possible, N2O5 is also possible. You can see, as I said, one element is constant, N2 is constant, and the second is changing, O, O2, O3, O4, O5 into simple ratios. Like here, oxygen is 16 parts. The molar mass, simple. The 16 is the number of molecular mass of oxygen. Next, oxygen is 32 parts. Next, oxygen is 48 parts. Next, oxygen is 64 parts, 80 parts. But nitrogen is constant, 28 parts. One molecular mass of nitrogen is 14 grams, 14. If we consider it as N2 means 28, 28, 28, 28, 28, 28. So the ratio will change it as 1:2:3:4:5:2. Very simple. So this is your law of multiple proportions. Hope you understood this. Let's move on to the fourth law. The fourth one, law of reciprocal proportion. Law of reciprocal proportions. Fine. So what is law of reciprocal proportions? Law of reciprocal proportions. This law is also very simple. You can see here, if I say H, this is hydrogen. If I say this is a compound A, and if I say Na, sodium, this is compound B, and Cl, this is compound C. I can say this law as reverse combination. If you see these two, sodium hydride is formed, NaH, and these two, HCl is formed. Okay, if we use NaH and HCl, we can form NaCl plus H2. Is it possible? So this is reverse combination, I say. Actually, reverse combination is not the word in your textbook or in your syllabus. It is my own word to understand it easily. Law of reciprocal proportion is the elements combined already. Two different compounds are taken. This one and this one is taken to form one more compound which can be formed by combination of these two. So this is law of reciprocal proportion. We can take one more example as hydrogen, sulfur and oxygen. We can form, here we can form H2S gas, here we can form water. Using these two we can form SO2. Am I right? So this is your law of reciprocal proportions. So these are your 4 important laws, combination laws. Which are all these 4? So let us revise them, all the 4. The first one is law of chemical combination, where LHS will be is equal to RHS. You should keep that in mind. I'll solve 2 questions. Only 2 I can solve because or else the video will go very long and it will become boring. I don't want to be bored. So let that be short. We will make it in parts. Okay. The second one is law of definite and constant proportions, that is whichever, if you take some compound, the compound will stay with the same moles of number of moles of elements everywhere in any way it is formed. And the third one is law of multiple proportions, that is different compounds will be formed keeping one constant and other will change in a simple ratios. And the fourth one is law of reciprocal proportions, that I said reverse combination. So these are your laws. Upon that we are going to solve 2 questions. The questions are, see, 3 grams of hydrocarbon on combustion with 11.2 grams of oxygen produces 8.8 gram of CO2 and 5.4 gram of H2O. If we see 3 grams of some hydrocarbon on combustion gives, combustion means it is heating in presence of oxygen. Am I right? So this is 11.2. On combustion gives CO2 plus H2O. So this is 8.8 grams and this is 5.4 grams. So they are asking the data illustrate the law of, which law it is. Is it a multiple proportion? Just remember what all the laws now I did. You can go back to the video, you can rewind and check. Is it a multiple proportion? Is it a constant proportion? Here there are so many compounds, so we can get these are all not. Reciprocal proportion, you might get confused. Conservation of mass, you might get confused between this and this. If it is reciprocal proportion, they don't give you the values in grams, so this is not possible. If it is constant proportion, then they should have given the reactant properly, so this is not the answer. If it is multiple proportion, then that is a different scenario. If we see for conservation of mass, let us add, as I already said, LHS will be equal to RHS. So if we add these values, 3 grams plus 11.2 grams, that will be 14.2 2 grams is equal or not. Let's see. 8, 14, 14.2 grams equal. Yay. Yes, exactly. This is the right answer. This type of questions you may get in your exam. So I have one more concept to cover. We'll cover it in next video, the mole concept, which is also very important. Just a mole concept will complete your physical chemistry to understand it easily. So we'll do it in the next video. Thanks for watching. Subscribe and like.